if we zoom in on this image, and I encourage you as you grab this image at home, like zoom in, you can really zoom in and play around. There are galaxies here in which you're seeing individual clusters of stars forming, popping up just like popcorn. And then we also see in the background of this image, kind of littered like jewels all over the back of the image are these faint
This is the day we get the first science images back from the James Webb Space Telescope.
Now, that was what we built the telescope to do.
To the cosmos.
The most distant of those are billions of years. We're seeing as they looked more than 13 billion years ago. And so galaxies like that one right there, this little red guy.
I'm Michelle Thaler.
Like,
Your host book can only be described as a celebration for everyone
Webb
on
got
Earth.
spectra
to
figure out what those galaxies are made of. And this is that one. We're seeing as it looked 13.1 billion years in the past. Less than a billion years after the Big Bang. And we're seeing the elements of oxygen and hydrogen as well as neon. This is how the oxygen in our bodies was made in stars, in galaxies, and we're seeing that process get started.
Yeah, I want to give this a little bit of context. So this is now the farthest away galaxy that we have this sort of detailed information about.
That we know what it's made of.
We know what it's made of.
Yes.
And this was not a long exposure for Webb.
No, the previous record holder, right, the Hubble Extreme Deep Field, was 2 weeks of continuous work with Hubble, and it was just imaging. With Webb, we took that image before breakfast. The amazing thing about Webb is the speed at which we can churn out discoveries. So everything that you're going to see here in this broadcast is a week, and we're going to be doing discoveries like this every week.
That is absolutely incredible, Jane. So thank you so much for joining us. It's been an honor to be working with you. Congratulations on all your hard work.
Thank you. It's so wonderful to see it pay off.
So thank you, and I'll see you later on today, I hope. So
yes.
Enjoy the day.
Thank you.
All right. So from distant galaxies, we now turn our eye to something a bit closer. It's a planet, but not one in our solar system. Remember that Earth and its sibling planets aren't the only show in the universe. When scientists and engineers started developing JWST, the search for exoplanets wasn't even part of the plan. That's changed. Exploring exoplanets is now a major component of the mission and the subject of our second big reveal of the day. I'm going to send it now to our friends Natalie Willette and Sarah Gallagher at the Canadian Space Agency in Montreal. So again, bonjour. I guess we're having a little... We'll go. Okay.
And I'm here to tell you.
Sorry for the brief pause there. We're now going over to Canada. Okay. Yep, we're all ready. Yeah. Okay, I apologize. We're having some trouble with the signal from Canada, but luckily for us, we have an exoplanet expert right here, just in case that happened. So this is Nicole Colon, and she's an exoplanet scientist at NASA, and we're going to talk about this amazing new result from a very hot planet, I understand about 1,000 light years away.
That's right. The exoplanet is named WASP 96b, and it is this hot, gaseous, giant, puffy planet that it is about 1,000 light years away. So that's why today's release is so exciting, because it teases at what Webb is able to do for such a distant.
Absolutely. So talk us through what this discovery is and why this is so significant.
Mm-hmm. Well, this reveal that you're going to see is going to show the first spectrum of an exoplanet as taken from the Webb telescope. And this is exciting because it covers infrared wavelengths of light that we have not had access to before. So we've been able to use other telescopes to explore exoplanet atmospheres in the infrared, but not to this level of detail. And this is just one sliver of data that Webb is providing us using the nearest instrument specifically.
And there's something about infrared that is actually particularly good for the spectrum. So in this case, what we're doing is we're actually going to take the light and break it up into a rainbow and look very, very carefully at how much color is coming in each part of the spectrum. So I believe we have that image, if we can put that up.
Okay, yes, I believe we're revealing the spectrum right here. So we now have our spectrum, and this is exactly what you're seeing, as you just described with spectroscopy.
I'm Michelle Thaler. Your
what
host
we
book
did
can only
was
be
we observed a
described as
transit of an
celebration for everyone on
exoplanet
Earth.
we
So think
observed
about this.
the planet
Life
as
from
it
the
passed in
earliest
front of the
days
star. Now,
universe
mind
has
you,
been
this is
traveling
not
to
a
us
direct
for
image. This
billions
is
of
an
years.
indirect image.
Just
So
over the
we've seen the
last few
effect of what
weeks,
happens
we've
when the
captured some
planet
of that
and its
light with a
atmosphere passes
telescope
in front of
that
the
sees the
star. The
universe in an
starlight filters
entirely
through
new
the
way.
atmosphere,
And today we share
and
the very
then
first
you
results.
can break that down into
So
wavelengths
longtime
of light,
space fans are gonna know
and
who
you
this
get a
is. This
bunch
is
of what
Dr.
looks
John
like
Mather.
bumps and
He's
wiggles
the
to
senior
some
project
people, but it's
scientist for the
actually
Webb
full
telescope
of
and a Nobel
information
Prize winner.
content.
And John,
So
I couldn't
you're
be happier
actually
to be here
seeing
with you
bumps and
today.
wiggles that
It's a thrill to
indicate
be
the
here.
presence of
It's
water
a very
vapor
special
in the
day.
atmosphere
How
of
are
this
you feeling?
exoplanet.
I'm thrilled and
So
I'm
we
relieved
have the
because,
spectrum
you
up
know,
here.
when
Is there
you
anything
start
you'd like
something
to
this
highlight
big,
particularly?
you know, there's always
Yeah,
a possibility.
absolutely. So
it
we
might
have
not work.
several
It did
features
work.
marked here.
We
So
are
I call them
proud.
features. They're
And you've been on
these,
this
what I
project
just
for
referred
a
to as
very
bumps
long
and
time,
wiggles.
right?
But
Yeah,
what you're
started
seeing
in
here is the
1995.
telltale signature, the
We had
chemical
just finished
fingerprint of
measuring the
water
Big Bang.
vapor in these
We measured it
atmospheres,
with the Cosmic
in the
Background
atmosphere of
Explorer
this
satellite
specific
that we built right
exoplanet.
here at Goddard.
And the other
And we
thing you can
measured
tell
the
actually is that
spectrum.
there's
We
evidence of
measured
clouds
their
and
hot and cold
hazes
spots in the Big Bang.
because
So
the
we said,
water
now we know
features
how
are
it
not
all
quite
got
as
started.
large as we
But
predicted.
then what happened after
So
that?
we can take that and
then
infer
I got
that
a
there are
call
presence
from
of clouds
NASA
and
headquarters,
hazes.
would I like
Right.
to work on
Now,
this
one
new
thing that we really
telescope
want to make sure people
that's gonna help
understand is with
answer
this
those
particular
questions.
planet, this is a
What
hot
happened after
world.
the Big
It's
Bang?
actually
How did the
closer to
galaxies
its star
grow?
than
How did the
Mercury is
first
to our
black
sun.
holes grow?
And so we're not looking at
What
liquid
happened
water
all the
here.
way from there to
But
here?
we're looking instead
So
at
this is
sort
our
of
time
steam,
machine, and
water
I just
vapor.
wanted to be
This
part
is
of it.
an
I'm so
exoplanet. It's
thrilled that we
about
got
the
a chance
size
to
of
do it.
Jupiter, about half the
One of the
mass
things
of
that I remember you
Jupiter.
saying is
It
kind of
orbits
amazing
around a
that you-
sun-like
after you
star,
win the
but it
Nobel
does it every
Prize,
about
you thought
three
that
and a
this
half
mission
days.
was the most
So it's
important thing
extremely
to do.
hot, extremely close
Absolutely.
to
It's
nothing
the
like our
next
solar
question.
system planets.
If you
But
know
that's
how it
okay.
started, what happened
because
then?
what we're seeing
And,
is,
you know,
again, the
suddenly
first
we now have the
exoplanet data from
technology to
Webb,
do it. We
and
didn't
this
have
is just the beginning. We're going to
50
start
years ago.
pushing down to
Didn't have
further,
the technology 25
smaller
years ago,
planets,
even when we
and
started
being
this.
able to take
We had to
measurements
invent
just like
things
this
along
with
the
the
way, so
nearest
we did
instrument
And
that
here it
was
is.
built by the Canadian
Well,
Space
thank you. We'll be
Agency,
back to you in just a
but
moment.
also
So
there's
at the
other
moment, we're gonna talk
three
about
other
the way
science
that Webb is a
instruments that will
completely new
add
way
to
to
our
explore
knowledge
the
in the
universe.
infrared,
So
as
today
well
the
as
mission
direct
releases
imaging
its first
modes,
science
along with the
images
transit
and
method.
gives
So there's a
wings to the
lot
dreams
more to
of
come.
so many
And I guess one
people
thing we
who
should
worked
mention is
so
not only
hard
are we going to be
for
looking
so
at planets that are
long
more
to make
like
this
the Earth
possible.
in the future,
For
but we'll
everyone
also be
on
looking at
Earth,
planets in our own
this is
solar
your
system.
telescope.
Absolutely, yes. We're going
This
to
is the
have
largest,
exciting
most
data from
powerful
planets in our solar
observatory ever
system,
put in
from
space.
Mars,
It's the product of
outward, as
thousands
well as
of people
asteroids and
working
comets.
for more
So
than 2
stay tuned
decades.
for a lot
This
more
is
to
a
come.
mission that's
Thank you so much,
singularly
Nicole.
focused on
Thank you
the
so much
biggest
for telling us
questions
about
in
the spectrum,
science.
and I'll
So
be seeing you
the
later on
following
today.
phrase is often used too easily. But
So
today
we have
it
3 more
actually
big
does
image
mark the
reveals,
dawn of a
and
new
with that
era.
new and more
Today
exciting
the Webb
science.
mission is open
But first,
for
let's take a look
scientific
back at the
business.
journey
And
that
this
brought
is
us to
just
this
the
moment.
beginning. The best is yet to
Celebrations
come.
like this one are only possible
So,
with
John,
years
one
of
of the
hard
things you
work from
told
a
me
cast
about
of
is that you
thousands.
really want to make sure
When a
there
new
are
mission
some
is
people
being
who get
built,
thanked,
even the
people
most
that put a huge amount
enthusiastic
of effort
space
into this.
fans only get to see
Absolutely.
dramatic moments in this
Our
life
current
cycle,
project
the
manager,
news
Bill
and images
Oakes,
that come out in updates and press
took the
releases.
project from
But
a
that
time
doesn't
of
really
trouble
give you the
when we
sense of the
didn't
huge
exactly
effort that
know
goes
how
on
we were gonna
behind the
get
scenes
this to
every
work,
day.
and got
The
it all the
plans,
way to the
schedules,
end.
and organizations
Here it is,
keep
it is
everything
working,
moving
and it's
forward.
because of
Really
Bill
happens
made
for the
this
most part out of
worldwide
people's
team,
gaze.
20,000 people around
Webb
the
started
world
as an
were
idea
involved
that
in
took
making
root at
this thing
NASA
all work,
Goddard.
and Bill has
It
been
grew
there
first into
every
planning
day,
teams,
making
research
sure
projects,
that it would
schematics,
happen.
requirements.
So,
Then it began
other
the
special
long
person
journey to
is
become
Senator
real
Barbara
with the
Mikulski.
development of new
She
technologies,
saved our
cutting-edge
telescope, and she
engineering,
saved the
and finally
telescope before us.
fabrication, putting
She
it all
made sure
together.
after the Hubble
Let's take a
telescope
brief
was
look
launched
back
and
at
was
the
not in
visionary
focus,
journey to
that
how we
would
all
go up
got
and
here
fix it.
today.
She made sure that happened.
So today
When the
was
Webb telescope
the
needed more
final
resources, she
closeout
made
of